If you could build a robot in hours, what would you build?
So, just a quick show of hands here. How many people here have seen some of our demos before? I mean, we have, so like lots of people have seen demos. So, Wayne, Wayne said we should do a talk on Ubiquity, about Ubiquity for Homebrew. And I said, great. And he said, but don't talk about the robot. Don't talk about the robot. Talk a bit about how we can, how you can crowdfund things, how you can make robots happen, and so forth. So I really struggled a little bit with, what we would call a talk. And I came up. I struggled a little bit with. I struggled a little bit with. If anybody wants to get up and move to this side of the room, I can do that now. I struggled a little bit with what we were going to call the talk, and I came up with this: building a robot is fun. Building 1,000 of them can be a real. And then I really struggled with that last word. What the last word should be.
It looks perfectly fine.
And I decided that beauty was the right term for the last. So we're gonna have a story in 3 parts. Well, the story goes like this. The first part of the story is, let's make a 50-pound payload. 100-pound payload. 250-pound payload robot that's inexpensive enough for guys like us to be able to afford it. And that was kind of the initial problem. That was the initial problem statement. The second part of the story is, well, we need a supply chain to do that. It's not okay just to be able to build one robot. We need to build a supply chain to do that. I'm going to be talking a little bit about supply chain in this talk. And then we need to fund it. So we're going to be talking a little bit about crowdfunding and all that. Ubiquity Robotics started with this problem statement. Create a low-cost robotics platform with meaningful capability to enable a broad range of applications. Why did we want to do that? Well, current generic robots were costly. It was about 15 at the time. It was about $1,500 for TotalBot. And those robots have limited functionality with short endurance, 45 minutes, and small payload, only a few pounds. This situation kind of hasn't changed. TotalBot 2 runs about 1480. TotalBot 3 Waffle with all the sensors is about 1800. And they still have short endurance. They still have limited functionality. And what we wanted was a robot that cost less than 500 to build and could thus be sold for less than 1,000 and can handle substantial payloads. Originally we said greater than 50 pounds, but that became 100 and 250 pounds. And I think all of you have seen me do this before. Right? You can stand on the robot and it drives around and so forth. Even people, you can even people. I've even had the courage to drive around on this thing before. So that was the problem statement. How can we build a robot with high endurance, payload, vision, and navigation capabilities for less than 500? And we started. The original version 1 robot was just a wheelchair robot. The $500 came because I said, well, I can import wheelchair bases from China for $250. The motor controller and computer, we surely can do that for another $250. It didn't prove to be that simple, and we eventually wound up starting to design our V2 design, which was a fully ground-up design of the robot. We actually put components of this into production. We then produced the V3 design, which had many manufactured components. In fact, many manufactured components that were made out in China, according to our design. But as you can see, there's still quite a lot that's not really manufactured or manufacturable. We then produced V4. That's starting to look a lot more like a product. And then V5 is the robot that I demoed here. And I think you've all seen. And what's going to be happening is that on March 10th, we are going to be crowdfunding it on Indiegogo. So if you want to get this robot, we will have it on Indiegogo. And yes, it'll be $9.99. It'll be under $1,000. The problem, though, about, oh, a little bit of a mistake there. The problem, though, with some of these things was really that you know, they weren't manufacturable. We had to start to think about supply chain, right? We had to start to think about supply chain. Here, I was just buying components. But as you go through here, you need to think a little bit more about some of the things that can go wrong when you're not just producing one robot, you're producing several. And so we're going to talk a little bit about how to not screw up supply chain, how to not do that. So we're going to play a game. Anybody here like games? We're going to play a game, and the way that this game works is that you each get to be a supplier, or get to pretend to be a supplier to Ubiquity Robotics. So can everybody sort of grab a few dice? Just one dice each. We've got about 50 of them, right? So we're going to start with we're going to play the supplier game. Here, just grab some dice. Hand them out. Good, Dave. The way that this game works is... The way that this game works is that you get to pretend to be a company that's trying to launch a product. The Hot New Hardware, this is a game that I do when I teach supply chain in Stanford. Okay? Hot New Hardware startup Widget Inc. is about to go into production. Widget Inc. has developed a product, has a contract manufacturer, and has a supply base. Each person in the room, or each person with a dice, is one of Widget Inc.'s suppliers. Rolling one represents an inability to supply. And the first person that rolls a 1 gets one of these cards. Now these cards, on it is a situation that actually corresponds to a supply chain issue that I have personally dealt with, or somebody who I personally know has dealt with. Now these are not all situations, these are not situations from Ubiquity Robotics, these are from all over the place, but they're people that I personally know, or I personally have had to deal with these things when I was a supply chain professional. Widget Inc. has several orders pending over the next few months. For the purpose of the game, 5 months. Each game is 1 round. And just to make it interesting, 1 month of orders contributes $1 million to an overhead of 0.5. We just have 1.5 million in funding remaining. So it's just a sort of hypothetical situation to give you a sense for what it's like to have supply chain issues. Okay, so if we can get started, we're in month 0. We have 1.5 million in cash remaining. And we all have to roll a dice. Anyone who rolls a 1, please raise your hands. Okay, anyone who rolls a 1. Okay, we've got a few suppliers who have failed. In fact, a whole bunch. Oh, wow, this is like...
Did you weight these dice?
No, I did not weight these dice. I did not weight these dice. Okay, we're going to, you get to pick a card, any card you like. And just, okay, so please read out what's on the card.
Flood at Supplier Factory.
Flood at Supplier Factory. Yes, I have seen this one before. I had some suppliers out in Thailand, and their factory got completely flooded. They shut down. Okay, so unfortunately for Widget Inc., we are now at 1.0. What's going on? Unfortunately for Widget Inc., we are now at 1 million in cash. Right? Okay, now let's roll the dice again. Okay, we got some more one. Okay, here we go. So let's go. So yes.
Okay. Inter-ethnic violence, aka civil war, erupts at Central African mine supplying raw materials.
This is actually something that I only had actually a relative of mine encountered about 2 weeks ago. Came in and he was, wow, you know, the mine, there's this, essentially civil war has erupted, we can't supply. Okay, so Widget Inc. is really kind of out of luck. They're at 500,000. Okay, let's roll the dice again and we'll get a couple more in. All right, now this is really what it feels like. Here we go, we're going to have a couple because we're running out. Here we go. Okay.
Oh, you just rolled a 1.
Okay, this is really what it feels like, to be honest. Okay, so can we read a few more? Actually, here's one more. Who else rolled a 1? Okay, just read out some of the issues that our suppliers are facing right now.
negligent failure to forecast demand.
Yep.
Blockbuster product, and to correct that forecast to production.
That's right. This is one that I actually dealt with. This was a company that launched a $2 billion product, and they had 1/10 of the production capacity needed to do it, right? So yeah, that's any others?
Snake infestation in Supplier factory.
That was a friend of mine that actually had a snake infestation. They had to shut down the factory, right? Right? I mean, this is real stuff. I mean, this is like every day you go up, you got to go to your meeting, and what the heck's going to happen today? Right? What else?
You've got an insect infestation.
Insect infestation, yeah.
Fire at factory that supplies components to suppliers.
Fire at factory that supplies components. Anyone else? Anyone else? Yeah.
Tsunami.
Tsunami. That's right. And this one was really interesting because it was a tsunami and it didn't affect any of our suppliers. Not one. However, because the tsunami happened, other people couldn't get their parts. And so they leaned on the people in our supply chain who then suddenly went on distribution. They said, well, that's what happened. We started to suffer, even though there was nothing affected in our supply chain at all, directly. But indirectly, these sorts of things can happen. So Widget Inc. unfortunately has gone bankrupt. They have run out of cash, right, after only 3 months because they didn't design their supply chain correctly, right? So what are the things, this is not very good. I mean, none of this is my fault, right? As the guy that's running Widget Inc. None of this is my fault. What should I do about it?
Why U.S.?
Buy U.S.?
Yeah,
Same problems happen in the U.S. too, right? I mean, it's not just the...
Who manufactures capacitors in the U.S.?
Okay, so...
Distribute your risk.
Distribute your risk, right? Distribute your risk. I mean, I always say you don't have a minimum viable product when you have a prototype. You have a minimum viable product when you have a prototype that you can manufacture, right? So we talk about lean methods and lean product development. When it comes to hardware, you need to have something that you can actually manufacture. So absolutely, just you try to spread your risk. So what can we do? Spread your risk. What else can we do? When you say spread your risk, what do you mean by that?
Redundant suppliers.
Redundant suppliers, dual source. Yeah. What else?
Building house.
What's that?
Building house.
Build in house sometimes, or sometimes maintain stock in house. What else?
Fewer parts.
Fewer parts. That's right. Fewer parts. So simplify supply chain, design supplies out, assess suppliers for reliability and mitigate issues. Keep burn rate low, right? One reason why Ubiquity Robotics is operating with no office at the moment is for this reason. We're going to talk a little bit about this and then we're going to replay the game again, 5 rounds, right? So absolutely simplify supply chain, reduce the number of parts. This is a chart. So I gave out roughly 40 die. That was no randomly selected number. That was because version 2 of our robot had more than 50 different suppliers. Version 1 and version 2 wound up having more than 50 different suppliers, right? Version 3, we reduced it to 22. Version 4, these are suppliers that are essential to the production of the robot. Version 4 had 7, and version 5, this guy, only has 3 major suppliers, right? Only 3 major suppliers. And we got there by designing out things that we needed to have. So for example, version 4 had a strap to hold the battery in place. I've got some, oh, by the way, yes, that's right. Support us on Indiegogo, March 10th.
Got it, David.
$2, please.
So,
20.
Burn rate's going up there, Dave.
So combine parts into one. So we did things like we took DC-DC converters on the same PCB as motor controllers. Design out parts with only one supplier. So for example, we had on V4 a high current on-off switch. We painfully redesigned that so that it would be a low current turn-on switch with solid state devices on the PCB. Could be manufactured by a PCB manufacturer. Didn't require a separate guy who specialized in making these high current switches. Completely designed that out. Switch solutions within the capability of your core supplier. So for example, you see on this robot, we have batteries that are held in by foam inserts rather than straps. Why? Because we had to have foam anyway for our packaging. Our supplier could do foam, they couldn't make straps, they had to have another supplier for straps. So we designed them out. We changed the design so that we could fit into the supply chain that was available. Get your suppliers to source minor components and work with them to solve issues that this may arise. So caster wheels. Oh, caster wheels. The weeks that I spent in China getting my, my supplier to redesign this part here for the caster wheels that are there. I mean, literally sitting there in the factory, they produced caster wheels, they did a design, they didn't work, we had to do the design again. You know, we didn't work, we had to do the design again, just so that the caster wheel can do this. And of course, at the same time, do this, right? Right, we needed to do both.
Wow.
And literally weeks trying to do that kind of change so that we could eliminate, because previously I was sourcing the casters myself. We wanted them to source it so that I could eliminate a supplier, but you know, created all kinds of other problems. And you know, generally, you know, the underlying theme here is rather than design your supply chain for your robot, design your robot for your supply chain, because then that's going to make your life a lot easier. But you know, these are all things that we did. Yeah.
Quick question, aren't you just putting the demand for different number of suppliers behind the guy who's doing your PCBs? He now has 40 different suppliers.
No, because, no, absolutely not. Because there are components that, there are components in, for example, the switch situation. There are components in there which, you know, it's a completely different way of solving the problem. You're solving the same problem, but with a different solution, right? So, because there's lots of different ways to solve any given design issue on your robot. There's lots of different ways in which you can solve any design issue on the robot, but you need to find solutions that come into the robot that you've got. So for example, this robot here is entirely made of, almost all of it is made of the same type of sheet metal, and it's all riveted together, because that's what our suppliers can do. Right? We started with a welded design. Turns out we couldn't get good quality on welding. Right? So everything on here is riveted together. There are no welds at all, because finding consistent quality welding was not something within our supply capability. Right? I think it's also important to think about this thing here is probably the last thing that you actually want to do. Right? You want to do things like this, or like this, or like this. This, you're right, has a little bit of what you're talking about in there. But in general, we try to avoid that one, go up here. Okay, so those are some of the things that we did to try to reduce the complexity of our supply chain. So we got down to 3 suppliers, and then of course try to dual source everything that we can. So the supply chain is simple. Now what do you do? Now the other thing that you want to do is try to actually assess supplier risk. And this is what that assessment looks like. You assess on a number of different dimensions. Operational risk. I'm going to be talking more about operational risk in a second. Quality risk, employee injury, labor unrest, country political risk, port transportation risk, credit risk, catastrophic site failure, natural disaster. Right? Try to look at all of these different things. I'm going to go in a little bit more detail, but I'm going to try to sort of move quickly over this. You know, the operational risk is the one that I actually spend most time, well, I spend the least amount of time, but probably the most amount of my mind share on, which is the failure of the factory as a system. And the sort of things that I look for when I go to a factory, I visit every factory that goes into this product. Do they have an operational system in place? Do they have a quick, clean, well-organized factory with standard work, continuous improvement, and JIT, just in time? Do they track and equip and improve equipment uptime? Those are the things that I'm looking for to see whether or not the supplier has the operational capability to deliver not just 1, but 1,000 of these things. I look to see if they've got a quality system in place. Do they have a quality mindset? Is the CEO a quality-oriented individual? Quality is one of those things that rots from the top down. If you have the CEO does not have a quality mindset, then you can be damn sure that you're going to get junk out of the factory. Employee availability. You know, do they have an employee safety program? Do they have a lost accident program in place? You want to make sure that the employees will not get hurt. Strike, labor unrest, is there a history of that? Country political unrest. Obviously, if you're running mining in Africa, this is a big one, right? and I know lots of people who do, port risk, credit risk, catastrophic site failure. A competent assessor will tell you whether the factory has more than 95% of the floor area covered with sprinklers. Right? Because factories do burn down, and sprinklers make that a lot less likely. And then natural disaster. Are there cataclysmic effects that can affect production? This is real stuff, right? I mean, like I said, there were, in those cards that I handed out, there was floods, there were tsunamis. That stuff really does happen, and it really will ruin your day if you're working in supply chain, right? Then you look at these sorts of things. Oh, I said I would talk a bit more about operational risk. I've done operations for a long, long time. I mean, I in fact started building robots because I spent too much time on the business side of things and too much time dealing with supply chain issues, and I wanted to do something more technical. And we started building robots, and that was lots of fun, and now I find I'm dealing with all the operational and business issues again. Right? Is that a question, or?
Well, yeah, I just want to say this list is fantastic.
Yeah,
is this
that's
something
amazing.
that you've compiled yourself and over your experience, or is this sort of a known matrix that people work from?
This list is, I mean, these are relatively standard. This list was compiled with me and actually a supply chain colleague who's done a lot of supply chain work before. Actually, is one of the people on the Ubiquity Robotics team helped me put this together as we were doing our supplier assessments. She was an individual who did supply chain for Toyota Numi and Cypress and SunPower. So she's been around the block a lot of times, and things like this have come up in many studies that I've done with other people and so forth. So I mean, is it completely standard? No, but I think most good supply chain professionals would have something like this in their repertoire. Okay, so yeah, assess all of these things. I said I was going to talk about operations improvement. How many people have seen something like this before? Anyone seen something like this before? A few? Okay. This is a lean house, right? This is, the analogy is, how do you build a good, operationally effective operation? Well, you start at the foundation and you build up. And if you do all of these things, then you'll get products with quality, cost, and delivery. So you'll get things with good quality, to low cost, and quick delivery. And it starts with 5S workplace organization, which is the factory tidy and well organized. Standard work. Are there work standards in place?
What does 5S stand for?
5S stands for sift, sort, straighten, sanitize, and sustain. It's basically tidying up. So the notion is that every day you have people in your factory, and they sift, they get rid of stuff that they don't need, they sort, they arrange things in order, sift, sort, straighten, they make things clear as to where everything should go, sanitize, they clean it, and then they sustain it. They do that every day. And it is very obvious if you go into a well-run factory whether they are doing their 5S program or not. Right? In fact, most of these things you can assess within the first few seconds of being on the factory floor. If you've seen it before, I've been to more than 40 factories in my time. I used to do this sort of assessment professionally for private equity guys and things like that. But 5S is basically, is the workplace organized? Because if the workplace is not organized, then it's almost impossible to do standard work. If you don't do standard work, it's almost impossible to do continuous improvement. If you're not doing continuous improvement, then you're not going to be able to do all of these more sophisticated things like just-in-time or stop-the-line process, and you're not going to get the quality, cost, and delivery that you need. Right? A lot of people go in and they try to implement lean programs by, oh, we're going to do just-in-time. Let's put just-in-time in place. But they don't. The factory's a mess. There's no discipline in the work floor. They don't have any notion of continuously improving. They're wasting their time. You're building you're building the house on a bad foundation. Right? That's the notion of the lean house. Don't start here. Start here. And once these things are in place, then you build up to get quality, cost, and delivery. That's sort of like the 2-minute version of lean, and I could probably speak for another 2 days on these sorts of notions. But But this is what I will look for in a factory. Oh, you know, is it properly organized? Do they have some notion of standard work? Do they have a continuous improvement program in place? Are they doing quality circles? You know, are they sitting around talking about issues and trying to make improvement? Do they have improvement projects? Do they have sometimes even large disruptive change events? Are they doing those kinds of things? And then, you know, do you have just-in-time and stop-the-line processes? Stop-the-line is if there's a quality defect, you stop what you're doing, you fix a quality defect before you have another problem. You don't allow the factory to continue to produce junk product. Now, when you go into a factory that's doing all of this, it's very obvious. It looks like the interior of a Swiss watch. Everybody's working, nobody's rushed, but everyone's occupied, right? A well-run organization looks like a Swiss watch. Everything's moving, but no one's rushing. And it's very obvious if you've seen it before. And so if I go into a factory and I look for I want to try to assess them on operations, this is what I would use. And this is the most important thing, because if this is in place, in general, everything else is in place. These factors, they don't usually happen in isolation. If somebody's doing this, usually this is going to be pretty good. This is probably going to be pretty good. This, maybe not so much. This you can't really control. But in general, this one will relate to several of the others on the list. And so, quick check, walk onto the factory floor, see if it's looking like at this level of performance or if they're really struggling with this. Try to sort of understand where they are in the performance.
So what percentage of factories that you walk into actually function like this?
I would say that out of the 50 factories I've been to, and remember, I purposely went to some very good factories, and I was sent to fix factories, so my distribution is kind of really skewed. I've seen some really great factories, and I've seen some real basket cases, right? Out of the 50 factories I've been to, the ones that are doing most of this would be maybe 2 or 3, right? 2 or 3. So maybe somewhere between 5 to 10% will be doing all of this on an operational point of view, right?
And how many are at the bottom or near the bottom?
The other 95.
I would say that about 50% of the factories are even struggling with this, right? 50% of factories are struggling with this. The ones that I'll tend to work with are the ones that are somewhere here, right? If they're here, I won't work with them. If they're here and they have some notion of a continuous improvement mindset, they have some idea about that, then you can actually work with them. You can actually improve them still further, right?
So all the 50 factories you went to were overseas, or?
No, I've been to plenty of factories in the U.S. I've been to plenty of factories in the U.S. There are excellent factories here in the U.S. I've been to factories in L.A. I've been to several factories in this area. Yeah, I've done lots of assessments like this. You know, I've been into all kinds of factories. I mean, I originally started in semiconductor factories, but I've done everything from, I've done coal mines to bread plants. I mean, you know, so I've worked on operational improvement in the whole gamut of things. So yeah. Yeah, I was a licensed coal miner at one stage because I was doing work in a coal factory. I told my boss, I said, I'd done 9 straight semiconductor studies, and I said to my boss, well, not one of the bosses, one of the partners in the firm that I was working, I said, I have to do something other than a semiconductor factory. Can you send me anywhere?
Careful what you ask.
Yeah. Sent me to Gillette, Wyoming, a coal mine. It was fun. It was actually a lot of fun. It was a lot simpler than a semiconductor factory, and a lot of fun. So yeah. So look at all of these things, and try to figure out whether the supplier is, you know, whether it looks like the interior of a Swiss watch or not, right? And or how much it doesn't look like a Swiss watch. And you can do this anywhere. I mean, I was showing Rohan how to do this in McDonald's the other day. I said, look at McDonald's, look at it. They've got standard work, they've got standard work, they've got workplace organization, they're doing just in time, stop the line processes, you know. Yeah.
But you've got another problem. You're trying to get 1,000 parts. Factories that are really well run probably have polished this over 1 million type runs, like auto
Right.
factories and stuff.
Right. I mean, so actually, if you wait just a second, I'll be talking about that exact problem in just a second. Okay. So you need to do your assessment of the factory, and then you need to sort of look at it and sort of say, well, do we dump this factory? Do we work with them? Can we mitigate? And your typical mitigations are going to be dual sourcing, right? So maybe the dual sourcing, designing out the part. If you've got a bad factory, we've had some bad factories on V4. We had a pretty bad factory. We got rid of that. Improving the speed of the response. Sometimes a problem isn't so bad if you can react to it quickly. To be honest, given that I'm doing a lot of this myself for Ubiquity Robotics, these areas and this one, I don't feel as happy as I otherwise might be. But improving the speed of response is typically something that you can do. And if you can respond quickly enough, then you can usually save the day. Sometimes retaining additional capacity or supply, for parts that are critical to us at a single source, we will retain units of those parts. We will own them and use them if we need to, right? So that you can maintain consistency of supply. Sometimes contractual mitigation will work, and working with suppliers to upgrade the capability. We will definitely be doing some of this, and you always should do some of this. Okay? So the supplier review, you literally go through the factory, you give them a rating, you think about mitigations, and then you come up with an action plan. That's a sort of normal thing that you need to do in order to eliminate supply chain risk. Okay. So now, who's got the dice?
Oh, here's the dice.
Okay, here's the dice. Okay, so we're going to play this game again. And we have gone and we have reduced the suppliers down to 3 suppliers, right? So like I said, we've gone from 50 suppliers down to 3. And we've tried to do our best job of assessing them and trying to sort of mitigate the issues that may exist. We can't be 100% successful, but we can be a lot better. So I need three volunteers. If I could just grab 3 people at random. Okay, here you go. You got one? Now I'm going to give you 2 dice this time rather than just 1. And for this time, for there to be a supplier issue, you need to thank you. For there to be a supplier issue, you need to roll both dice, and both dice need to be a 1. And we'll see how it goes this time. Okay, we'll see if we can do a little bit better, having designed out and tried to do the sorts of things. This is not a guarantee, this is all probabilistic, but let's roll the dice. Okay, anyone got a 1?
Got 1-1.
You've got 1-1, but no, not 2, so we're okay. We're okay. Okay, so hopefully we're gonna survive. Okay, we're gonna do another round. All right. I don't know how much we're gonna make on this round. What, 1.6? Whoa, 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 whoa.
You make $500,000 if you're right, don't you?
All right, so it's not being very, 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 very nice. But anyway, okay, we're gonna do another round on this. I'm not gonna bother with this, but 1.6. We'll see. Okay, let's do another round.
1-1.
1-1, 2 1s?
Yep.
2 1s. Okay, well, so what is it this time?
Go to jail. No, wait. Fire at factory that supplies components to supplier.
Right, happens. Happens. You do all of this, bad things still happen. And so we lost 1 month. It decided to work. So I'm doing this in my head. So, okay. 6. Okay. Okay, let's roll again. Okay, so, things seem peaceful in the supply chain department,
Dumb question, you got money coming in because you're able to sell your product?
That's right, we're able to sell the product. So each round, I think I set it up front, we were able to sell the
Bill's
product.
got 1 and I've got a 1. Does that count?
No, that's, this is playing silly
There's
buggers.
more creating problems.
Little collusion there.
Yeah. Okay, so, let's roll again. Round 4. Okay. Right? Sounds all peaceful, right? That's what a good supply chain organization should sound like, right?
Yep.
Yeah.
When it, right? Any other ones?
Nope.
No? So yeah, I mean, we're still here. We had a bit of a hit, you know, we had something bad happen to us, but we're still around. We didn't go bankrupt in 3 months.
Why would we not each take one die though? Because obviously 1 and 1 together is like major low probability
Right.
relative to.
Right, because we've gone and we've done our supplier assessments, we've mitigated the risk from each supplier. We've looked at each supplier and we've said, you know, we think that there is either low risk here or we've mitigated the risk and we think that the risk has dropped. Because for sure a bad supplier, I mean, you've got a 1 in 6 probability of something going wrong with a bad supplier.
That's pretty bad.
A bad supplier will be much worse than that, right? A bad supplier, yeah?
There's some sort of equation that you calculate based on your study, that you have some sort of number that you put in together with some formula to compute that probability.
Lots and lots, lots of things like that,
Okay.
if you want to get into detail.
Okay.
The reality though is that when I first started doing this sort of work, I would try to come up with a perfect analytical solution. And over time, I just, you know, became too complicated to, I used to do a lot of that sort of thing. I mean, I did like, you know, once in the coal mine, in fact, I did a clustering algorithm that proved that the mine would pass into different states. And, you know, my colleagues thought it was interesting and so forth. The miners, you know,
They get glassy eyes and.
they thought it was brilliant, but they didn't understand it at all, right? I mean, I was able to show that the mine would take, but yeah, various different states. So the point is, a bad supply will be worse than 1 in 6, right? A bad supply will let you down more often than 1 in 6. A good supply will be much better than 1 in 36. A good supplier is, you know, will have a failure rate, on-time delivery, perfect delivery of better than 1% is a good number, right? I've seen good suppliers trying to get their perfect delivery number up to maybe 0.5%. So bad suppliers, they don't even track it, and they're, you know, they're like, you know, perfect deliveries at like 80%, right? So these numbers that I'm giving you, these are not, you know, pulled out of the air numbers. I mean, they kind of represent reality, and they kind of represent what we've done with this particular project. Now, can I guarantee that nothing will go wrong when I bloody well think that stuff will go wrong. But hopefully we have reduced the risk that something will go wrong, right? You know, that's the sort of thing that obviously we're here to do, because we want to make sure that our backers are happy. Okay, so at the end of 5 months, at the end of 6 months, we are still here. What was the difference? What was the difference?
Better suppliers.
Well, better suppliers, you know, reducing the risk in design, right? It's not the supplier's fault, it's our fault. We're responsible, right? And so on. Now, this is to answer your question. Well, you know, why can't we work with, like, you know, Han Hai, they've refined this over millions of units, and so on. You absolutely can. This is a sort of, you know, conceptual chart that sort of describes this. I mean, you can work with, and in fact, when I do some of this is actually specific to here, but sometimes when I do this in Stanford, I go through lots of case examples. You can work with top-tier guys like Han Hai, Flextronics, and so forth. Typically requires a high commitment of capital. There's typically a pretty high incoming quality requirement. There are plenty of startups in the Valley who were started with guys in the garage who could not meet the design rules of the Flextronics and the Han Hais of this world. You need actually quite a lot of expertise just to be able to hand them a design that they will accept, right? And there's a relatively complex business process to set up. And the other thing that often happens is that you get scheduled deprioritization. So you give them a design, and Apple comes in and says, look, you know, iPhone sales are going really like gangbusters. I need more iPhones. Who do you think Han Hai is going to service first? Apple or you? Right. Right. Typically pretty expensive component with quotation. So these guys, you're right, the quality system, that they have great quality systems. I did stuff in Flextronics myself. Actually know the former chairman of Flextronics. Right? Great companies. Tough to work with if you have a small team in the garage. you can, so don't deal with these guys unless you can do rigorous design requirements, unless you can deal with the rigorous design requirements that they will want. Second tier, capital commitment is lower, service quality is actually only a little bit below these guys. But these guys are very, very good. Or you can work with the small size CMs. Now, these are much easier to get into. They tend to be very flexible. I mean, I go to China and sit with the engineer in China and work with them on design elements of this.
You know, what you haven't mentioned is that Dave happens to know something of Mandarin.
This is true. I speak Chinese, but you know,
It's valuable.
That's true. That is true. Okay. You know, I sit and I can talk to the engineer, and we can work out a lot of the problems right then and there. We can put it in the design, and then they can put it on the production floor. You are not going to get that at these guys, right? They're pretty flexible. They're easy to set up, and they'll support your schedule better than these guys probably will. The downside is that these guys typically do not have the fabulous quality systems that these guys do. But if they're reasonably good, you can work with them on that. And obviously, we have in Ubiquity Robotics quality system guys. That's exactly what we're going to do. Now, are we all the way up here? Absolutely not. But we are working on it. Right? And until, as we get more volume, we will be able to move up here. Okay? All right. Does that make sense? That's all I thought I'd on supply chain, right? Okay. So now I'm going to talk about funding. Now, the problem that you have with doing anything like this, of course, is we wanted to produce a robot, and we wanted to produce it for less than $500, so that we could sell it for less than $1,000. And that's really kind of hard if you're only producing a small number. This is Loki. This is our, as you know, we've got two robots. We've got Magni, which is the big robot, and Loki, which is our small robot, the little guy. This is what the economies of scale look like for Loki, right? We're going to be crowdfunding Loki at about $119, which is roughly what it costs. Basically the cost price if you don't produce very many units. But as you produce more units, the price drops per unit, right? You're able to make volume purchases of parts. The contract manufacturers' setup charges tend to get amortized over more units, and so your cost per unit drops. It's actually a pretty terrific price that we negotiated with those guys, right? It's close to the BOM cost. But you need lots of volume in order to do this, which is why we're crowdfunding it, right? Because for us to be able to supply you guys with robots at sort of prices like this, our pricing is pretty simple. What would it cost you to produce one of these things? In fact, for Magni, it's worse than that. What would it cost you to produce 10 of these things or 20 of these things, roughly, is what our pricing is going to be. And we rely on the fact that we're going to get a large volume of orders through to be able to supply these things at terrific prices, because that's what we wanted to do, right? So you need volume. That's the first thing. The second thing is, generally, this is how pricing terms work with your contract manufacturers. If you're new and you haven't developed a supplier relationship, they don't know who you are, and you're purchasing in relatively small volumes, they're going to expect you to pay 100% of the component purchases up front, and they're going to expect you to pay the contract manufacturer up front. And then you will wait for your parts, then you pay a load of logistics, and then maybe you're going to have to pay to store the inventory. And that's typically how you start out, right? Over time, if you know these guys, and we've been working with some of our guys now for some time as we built this thing, maybe they'll cut you a bit of a break and they'll let you pay for the components in the CM a little bit after you place the order, which we are currently at with our suppliers. If they know you and they trust you, then they might allow you to go maybe to here or even to here. And we've actually gotten to quote us terms here if we produce a large order, which means that we pay about 30% up front and then the rest on delivery. But they will only do that if they've known you for many years and you're going to put a large volume order through them. And if we can get down here, our cash conversion cycle drops, and that means that we can supply robots more quickly to people, and we can do so with less working capital, which obviously is what we're going to try to do because we're super lean. I mean, we are like, 3% body fat lean at the moment, right? So yeah, and that's kind of where we're going to go. So yeah, so contractual terms tend to improve the longer your relationship, the longer the time you've had a relationship with your suppliers, and also it improves if you can put it in a volume order. So if you think about it, you need volume, you need upfront funding, and I don't need to tell you guys about how important developing a community is. You need all of those three things, hence crowdfunding, right? And that's why we're crowdfunding this. If people don't like what we've got, if people don't want it, we absolutely can't do it. We have a fixed funding goal for our product, and our fixed funding goal is basically break even for us, right? Now we hope that we get lots of support from the community and that we get lots of interest from the community and that we can exceed that goal. But if it's below our fixed funding limit, we simply can't produce these things at the prices that we're offering, right? So yeah. Okay, so crowdfunding. And of course that means that we have Indiegogo on March the 10th, so I do hope that you will all come and support us. So yeah. Okay. And that's why we went for crowdfunding, because we wanted these three things. We need volume, we need upfront funding, we need community development. Those are the things that we wanted. Okay, so key points to think about with crowdfunding. Crowdfunding is great because if it works, you get these three things. You get a community inbuilt, you get upfront funding, and you get volume. All of which you need in order to be able to produce something like this in any kind of reasonable way. You need to try to think about how to acquire your prospects before day one. So really, for a successful crowdfunding campaign, you need about 30% of your goal to be achieved on day one. Is kind of what you want. Now, if you're going to acquire all of that through online advertising, it's going to cost you about 50 cents to $2 per email collected. So per person that you have who might be a prospect, it's going to cost you about this much. Now, only about 5% of these people are going to convert. So you can see that your cost to acquire a customer is going to be between, it's going to be in this sort of order of $5 to $20 per person before day one, if you do it all through online advertising. But building your community is the point. Building a community is kind of the point. Now, crowdfunding, it was a pretty good gig back in 2014, 2015. Things have changed a little bit. There have been a lot of people who've come out who either failed because they didn't understand some of the challenges of doing a hardware product. They were either very late, or frankly, because they were fraudulent. Does anybody know a fraudulent crowdfunding campaign? Right? So there were a lot of people who've come up with failed, late, or fraudulent crowdfunding campaigns, and that's caused people to be more wary. So it's much harder to get journalists interested unless the campaign looks like it's going to be a blockbuster. The major platforms really do not drive traffic to campaigns anymore. It used to be that you put your campaign on Kickstarter or Indiegogo, and you'd expect about 30% of your traffic just to come from people who are surfing Kickstarter and Indiegogo. That's no longer the case. And then also be wary of promises by crowdfunding organizations to help you. I will not mention any names. Just be a little bit careful, because there are lots of people out there who are trying to claim they can help you, but not all of them can. Right?
What are their initials then?
Well, Indiegogo promised us, oh yeah, we're going to do all kinds of PR help and so forth, and it's been a bit lack. It's been a bit below expectations, to be honest. Right?
What do you mean by the Kickstarter and Indiegogo don't drive traffic to campaigns?
Used to be you put your campaign on Indiegogo or Kickstarter. You'd ask all of your friends to sign up. They'd sign up. You'd get maybe 10, 20% of your traffic, 10, 20% of the people, 10 to 20% of the people that that went to your campaign and bought something in your campaign would be friends and family. Maybe 25 to 30% would come from press. And you'd expect about 30% of your traffic to come organically from Kickstarter and Indiegogo itself. So people would surf on Indiegogo, oh, that's a great project, I need to support that, yes. Right? These days, that kind of traffic, the traffic that was just, people surfing on Kickstarter and Indiegogo, just is not as high as it once was.
Okay, it's because there's not as much traffic surfing these websites.
That's right. People are not surfing the website as much. You have a small number of super backers, the guys who back thousands of projects. They come in and support it, but the sort of interested parties who used to surf the sites before don't seem to be surfing it as quite as much. Or there are just so many more projects now that each one gets less attention. So the environment is less favorable, but we still feel good about crowdfunding, and we still are excited by our campaign, which is going to happen on March 10th. And because for these reasons, the need for volume, upfront funding, and community development. So yeah, and I can tell you, building a robot on a crowdfunding campaign, it's so much more fun than what I used to do. Even though I do have to deal with all of these issues, which I used to do. That doesn't pay as well, but it's so much more fun than what I used to do. So, summary, it's been a journey to get here, right? It's been a journey to get here. It's been tiring, it's been exhausting, but it's been good. Supply chain is a major issue if you want to produce more than one robot, and should be addressed with both design and other means. In fact, in traditional supply chain organizations, designing out your problems designing out your supply chain, getting rid of your supply chain problems in design is a really totally underutilized tool. In general, you have the supply chain organization that's completely separate from the design organization. And there are so many problems that you can get rid of if you have supply chain guys thinking about the design of the product. Because you can get rid of huge numbers of problems that way, but almost nobody does it. Crowdfunding opens up many opportunities, but it isn't as attractive as it used to be, right? It isn't as attractive as it used to be. So yes. Okay, thanks very much, guys. Oh yeah, any questions? Sorry. Questions?
Yeah, one question about the crowdfunding. So March 10th, what made you decide that date versus another date? Are you having a particular campaign that you're running?
So March 10th is, we're going to be doing a big exhibit in San Francisco called World Fair Nano. It happens to fall on March 10th. Otherwise, we definitely would not have chosen that date because it's a Saturday, and they generally think that launching your crowdfunding campaign on Monday, Tuesday is usually better.
What's the event called?
World Fair Nano. It's kind of a bit like
World Fair Nano.
Yeah, it's a bit like it's a little bit like Maker Faire, but smaller and seems to be a bit further out, right? So you can come and see us. We'll be at World Fair Nano. We'll be launching the product there, a bit like in Maker Faire. So our goal is to start in World Fair Nano and finish in Maker Faire, although we may have to cut the campaign short before Maker Faire. So get in early. Yeah.
So I would have thought 3.14 would have been the obvious start date for this thing. But, so what will the campaign look like? What is your expectation? What are the price points?
Okay, great question. Thanks for that. So the number one thing we're trying to sell on the campaign is this guy here. This is Magni Silver, right? And this is a robot that navigates, it's location aware and it's object aware, and it can carry 100 kilos. So it has a navigation system. You've seen that. It has a deep neural net recognition system. You've seen that. It has obstacle avoidance and so forth, right? And that's going to be launched at $999, just under $1,000. We have another version of this that we call Magni Gold. That's going to be same as this, but instead it has 2 time-of-flight 3D cameras. These are not structured light cameras. They are true time-of-flight cameras. Each camera gives a 120-degree field of view. They are 2 cameras together. There's some overlap. All in, it should give a 210 field of view.
Is that the people on Arquez that's doing this?
No,
Okay.
we designed this ourselves.
Oh,
And it is intended to be a LiDAR substitute, right? Because you have true time of flight, you have a 210-degree field of view. We are intending for it to be a LiDAR substitute, but as with all of our stuff, we don't know what people will use it for, and if you get the service calls that I get, you stop trying to anticipate what people will use it for. You just try to give it the functionality that you'd want, and then people will come up with things that are completely different.
what's that price point?
So we have Magni Silver and Magni Gold. Going down a bit, we will have a bare bones version of Magni. That'll be a little bit less expensive than Magni Silver. So that's Magni, but it won't have the computer or the sonars or the camera. It'll basically be intended for you if you want the chassis, but you want to put your own computer on it. We then have Loki. Loki is a small bot. I think we've shown it in the club. It's a single PCB robot. Again, differential drive. And we're going to have some early bird specials for Loki at $99. But there will only be a limited number of early bird specials, and you'll know why, because actually if we only sell the early bird specials, we actually lose money, right? Then I think the regular price is going to be about $119 for those guys. Then we will have Loki with Raspberry Pi and camera, and then Loki with sonars, and then Loki with Raspberry Pi and camera. So Loki with sonars is Loki Silver, and then with Raspberry Pi and camera is Loki Gold. So again, Loki Silver will be, I think, about $199, and Loki Gold will be about $249.
And Magni Gold?
Magni Gold will be $1,499. And then we will have a few other kind of higher end Magnis for people who want everything. We'll have a Magni All-In, which will have Magni All-In comes with, let me see if I've got it here.
Kitchen sink.
Magni All-In has the kitchen sink. It also has, so this is a version of Loki. Magni All-In comes with a board. It's called the Juicy board. It allows you, it's a motherboard style board that you can plug servo controllers into. It will come with 6 servo controllers. It will come with some general purpose FETs that you can switch on and off with the Magni board. It will come with a screen. The robot will come with a screen, and that's going to be $2,999, so just under $3K. And then we might have some specials in there as well, like choose your own color or hang out with a team. You know, I don't know about the hang out with the team thing. I think that might be not very good value, right, for whoever selects it.
So roughly how many people are you looking to attract?
So if we assume that people who buy Magni Silver, if it's just Magni Silver, if we can get 200 people to get a Magni Silver, then the campaign will meet its funding goal. We're trying to get 60 people to sign up on day one. And oh, by the way, if you want a super special early bird discount that you will not be available after March 10th, give me your email now, because we will send one out to you. So we need 60 people or 60 robots purchased on day one is what we ideally want, and 200 Magni Silvers purchased during the campaign to get it.
I'm not sure if everybody's aware of how that works, but can you explain the issue of why there's a thing?
Yeah.
What does that mean?
So the way the crowdfunding works is as follows. You sign up and you say, we want to have a Magni Silver. I am willing to pay the $9.99 for it. If enough people also get a Magni Silver, then the funds get debited from your credit card. We get the funds, minus a few fees, and we go and produce the robot. Right? So we've set our campaign goal at 200,000 US, right? If 200 people buy a Magni Silver, or some mix of Lokis and Magnis, whatever the mix is, but if we get $200,000 in the campaign, then we go away and produce it. If we get 199,999, we do not. Right? It is that simple. And that's controlled by the Indiegogo system. So you give your credit card to Indiegogo. You don't give it to me. You give it to Indiegogo. And if they, if we reach the goal, if enough people say, I'm willing to do this for $9.99, then the campaign funds and we go away and make them. But if it doesn't get there, then we don't. And that's how it works.
So David?
Yep.
While we're on the topic, do you also have like a high-end limit so you can avoid getting buried by overwhelming love?
You know, you're not the first person to by the way, if you want a discount, we'll send you guys one, especially if you give it, put your email in. There is no high-end limit, and that's what we would describe as a high-class problem.
It could be a problem if it gets back to supply chain capacity. Right?
We have computed our supply chain capacity, and we will not run out of supply chain capacity unless this is the largest crowdfunding campaign for a non-cryptocurrency offering in history. Okay? So I don't think that, I mean, maybe I'm wrong. I hope I am, right? But unless this is larger than any other non-cryptocurrency offering, we're fine. And even then, I probably can figure it out. Okay? So yes, right? But yes, there's no upper limit. Now, that said, if we start to raise too much money, I'd rather not give that money to Indiegogo. So I will ease off the gas, right? So far, we've had about 2,500 people who are sufficiently interested to give us their email, right? All those people convert into a Magni Silver and we'll have no problem.
Really
Yep.
special secret offer.
Who are your expected target customers for high-end Magni? Are they corporations or are they individuals?
Well, we designed Magni for us. We wanted to design a Magni that we wanted to design the robot that we wanted, right? So Magni is really squarely aimed to enable people in the garage to build their robot applications. You know, all the stuff that I show in the video here, right? I mean, all of this stuff. You know, we want people to do this sort of thing, right? We want people to do the sorts of things that we have in the video, right?
I want to show the video.
Let me show the video.
Yeah, show the video is the last thing, okay?
Yeah, sure.
When is the expected delivery?
We expect there will be a trigger point, some point during the campaign where we think that the campaign is going to go or not, and it's about 5 months after that time, right? Because we've got a few things to deal with. So I'm going to just take 2 more questions, and then we're going to have to close. We have to ask some questions outside.
So who provides the advertising to all the people that don't even know this thing exists to know that they want one?
So we've been buying. I have been paying for advertising, right? So.
I haven't seen it.
Okay, you know.
I consider myself, you know.
Guess what? Are you on the mailing list? It's coming.
Okay, the majority of our advertising spend will probably happen between now and campaign date, right?
Is it national, international?
Yeah, so we're doing advertising in 33 countries of the European Economic Area: Canada, US, Japan, South Korea, Hong Kong, Singapore, Australia, New Zealand, and Russia. So 39 countries.
Scientific community or who?
We have tuned our advertising to those to be similar to the people who have already expressed interest. So it is similar to, you know, demographically similar to people who have already expressed interest, similar interests, similar sorts of things. We might have missed you, right? And you know, the advertising budget is like everything else, super lean. So you know, there's a good chance it won't have hit you, but it's hitting some people because I've already got, you know, about 17,000 people who visited our website and about 2,500 people who are interested enough to give me their email. So
is it an email campaign or is it social media with Facebook and?
We're doing
Yes and yes.
yes, yes, and yes. So we've got an email campaign running. We've got social media where we've got lookalike campaigns running on Facebook. We have search ad campaigns. So, for example, people. The other reason why you might not have received the campaign is it's actually an expensive area to, Silicon Valley is an expensive area to target, right? So it may just be that you got adversely selected out of our campaign because it would just be expensive to reach you, right? And so we go through an auction system. We're trying to find people who have an interest in ROS and robots and so forth. So it may just be a targeting thing, but we have ads running a lot in a set of developed countries that we think are the right places to target. Like I say, we've got thousands of emails. Whether or not it will work, God knows, right? And God, I hope so, right? But it's kind of partly, tell your friends if you like what we're doing. Tell your friends, get excited about it. Tell other people. Okay, one more. Chris.
Are we going to see either of these robots at RoboGames? Entered in any contests?
I hope that one of our backers buys one and takes it to RoboGames soon.
What does it weigh?
What's that?
What does it weigh?
13 kilos without batteries.
Yeah, it's in the specification.
If I will tell you, for me personally, if the campaign goes, I'll either be so busy trying to get this stuff sorted out, or so exhausted that I am sure that it's the same problem. I left. I quit doing like supply chain and business stuff so that I could spend more time doing technical stuff. And now I seem to be spending all my time doing business and technical stuff, only I'm getting paid half as much and working twice as hard. So, go figure. So, yeah. Okay, thanks so much, everyone.
Thank you very much.
Support us on March 10th.